Hey YouTube, it's JP Dillon. Today we're looking at a 1992 Sony HST-D105. This is an all-in-one stereo system. It's a radio, a preamp and equalizer, a cassette deck, and there's an outboard turntable that's not seen here. But this came in because there was a complaint of intermittent noise in the right channel, and the noise was there regardless of whether the volume was up or not. So I've got it hooked up to the test bench here, and let's turn it on. And let's see here, heard a relay click, so that's a good thing. I've got a signal piped into CD, which is over there. Okay, so they said intermittent noise. Let's turn the sensitivity up. And all right, there it is. So you can see in the right channel there. Little bits of noise. Let me see if I can get a way to amplify this. I don't know if y'all can hear that or not. I plugged in a set of headphones and stuck it up next to the mic on the camera. Well, anyways. Yeah, the noise seems to be getting progressively more frequent the longer it's on. So let's open it up and see what we can find here. This is kind of what I'd expect. A lot of air, but it has a power transformer in it. And it's got a reasonable size heatsink and what looks like some sort of discrete transistors there. There's the cassette mechanism. We're not going to be dealing with that. Let's take a look over here. Oh, it uses these things. These little old sinking, it's like an SK 1870 something. 1875, 18753. I think that's the number. I can see in here. Yeah, hard to see in here. Tilt this thing up a little bit. I used to change these things out in old Sony home theater receivers. Yeah, I think it's an 18753 or 752. Okay, 1875. Yeah, it was close. Going by memory. Yeah, these are little like 5-pin fully encapsulated audio amplifier. It's about maybe 5 watts. So these used to be problematic in home theater receivers because they'd use them for the rear channel amplifiers, Sony receivers in the 1990s. How's that regulator looking? Actually, it's okay. Yeah, the soldering in this one isn't that bad. It must be a low hour set. You don't typically, yeah, there's no breakage. It's just, I don't know, looks all right. So let's see what happens if I tap on that device. No real change. And I know it's, let's see, that's the right side because I can affect it by touching it. Let's see what happens when we get some freeze mist on it. And just, you know, standard troubleshooting freeze spray. I'm going to spray this thing and I'm going to see if the problem goes away. Gotta wait for it to cool down some. Yeah, it gets a little less, doesn't it? Doesn't go away, but it sure does get a lot less. So that could be it. Let's look up the data sheet on this device and see where the input pin is. And we'll scope it out just to make sure that the noise isn't coming into the device. It's just there. Yeah, it looks like signal comes in on pin 1, leaves on pin 4. Alright, so I'm going to scope out pin 1. And in comparison, doesn't look like there's anything going in. And if we go to pin 4, yep, there's our junk. So since there's nothing coming in here, let me crank up the sensitivity on the probe. We'll go from ×10 to ×1. We'll see. Yeah, I don't see any garbage there, so I think we're good on replacing that. We're just going to replace that. I think I have one or more of those kicking around somewhere. If not, I can order it. Okay, so fast forward a bit, I did end up having to order this. I didn't have one, so I got this from Dalbani Electronics. I think it was like 13 bucks. So now it's a matter of getting it in here. And it looks like the way that we're going to have to get it in here is take this board loose, because you've got a support bracket down here you have to remove, but that doesn't give you clearance for the mounting screws. So then there's another mounting screw back here, and then we have to take loose this. Probably just pull the whole board forward and up to get it out, and go from there. Alright, so let's get cracking on this guy. See what we have to do to get access to the amplifiers. Yeah, that's going to want to come all out as one. And since I took the cover off, there isn't anything supporting this side, so this is like floppy. I wonder if it would be easier to just tilt the whole thing down here. What happens if we take this loose? And then maybe, yeah, that works a lot better. Let's unplug this. And does that give me a little more freedom? It does. Okay, so there's a support bracket here that we still have to undo. But that way I don't have to disconnect a whole bunch of stuff. So we'll remove said support bracket. I'm just going to hold this with my other hand since come on out. Don't try to fight it. Alright. That gives me access to the heatsink. So now I can unsolder this guy and take him loose. And then we'll just replace him. And hopefully that will cure it. But everything that I found thus far should suggest that that should fix it. These things were really popular in the 90s. Dorm stereos, if you were on a budget and you just wanted halfway decent sound, they were pretty good. With this kind of power, 5 watts or whatever, it's not going to blow you out of the room. But these were usually sold with fairly efficient speakers, so it typically wasn't, it was loud, it wasn't hi-fi, but it got you there. This one solder connection here is just trying to fight me. I really don't care if I overheat the old device, because obviously it's coming out. Just this one pin here. Alright. So we should be good there. Let's take the screw out for the device itself. And wiggle, wiggle. Alright, so he's out. Let's get a shop towel and clean all that old heatsink goo off of there. Alright, that's pretty good. And we'll take our new device and we'll take our new heatsink goo, and I just hack off the butt of a Q-tip and use that to spread it. Just put a nice thin coating on there. It doesn't need to be excessive, just enough to work. And we'll feed it through the holes. And I gotta get this all lined up again. We'll put the screw in here. Never solder anything until everything's secure. Otherwise, you usually end up breaking foil traces on the boards. Okay, that's secured. Let's reinstall our little bracket. I think that's how this goes. Gotta love magnetic tools when you can actually get the head of the screw on the bit. I'm not going to fully tighten that yet until I get the heatsink lined up on this side. There we go. And now we can crank them down. All right. Now let's go ahead and reseat our board and our back panel. Okay. Gotta make sure that's there in that position. That's probably where that ground screw is going to go. And then we got this here. And then finally I'll put the middle screw back in the rear panel here that we had to take out. Okay, Now everything's in. Let's go ahead and solder it. And the stock leads are a little excessive, so you will be trimming them. I'm just going to take the butt end of my X-Acto knife and scrape carefully between the leads. Make sure there's no solder fragments or anything that could create a bridge. We'll do that again after we solder it. And you want to use a really fine pencil tip here because these pins are really close together and it's really easy to create a short circuit that would destroy all of this work you're doing. Okay, and again, we're going to scrape between here, make sure that there's nothing between the leads that could create a short circuit. And then we'll take our flush cutters and trim all this off. There's a solder flake right there. Okay, so that in theory is the replacement of our power amp. So let's plug it back in and see where we're at. Alright, so it's either going to fly or it's going to fry. Let's see what happens. Click, that's a good sign. I do have both channels here, which is good. Let's crank up our sensitivity again and see if we get any noise. Definitely would have showed up by now. So I think we're good. Very nice. That was an easy fix. And then let's see here. Move the sliders up and down. I expected them to be noisy, but so far, messing with the EQ sliders, nobody's noisy. Let's see, balance. Yeah, that works. Bass boost, that works. Okay, so we're pretty good here. Oh, one last thing. Let's see, this has a protection relay on it. So let's see if I tap on it. The relay is problematic. Oh yeah, it is. Look at that. Tap on that relay and that sound goes away. Okay, so we need to replace that. And that's this guy down here. The little black guy there. Whopping 2 amp. Yeah, I got something better for that. Alright, so that's the relay's this guy right here. You can't really see the lower pins because this is in the way. But you've got coil pins and speaker pins there. It's only a 2 amp relay. But that form factor is pretty common. I've already got something in mind I can replace it with. Let's see here. Not that one. Here we go. Alright, so what I'm going to replace it with is this big old Ortophone, or Omron rather. This is the G2RG 2A4 DC24. So basically, same relay that's in this thing, but instead of it being a 2 amp device, it's an 8 amp device. It's a little bit beefier. So very unlikely that there's going to be any problems with the contacts getting crummy. And I can see why they chose a 2 amp relay, because at 5 watts into 8 ohms, you're not going to draw more than about 3/4 of an amp into 4 ohms, I think. Don't quote me on that, but that sounds about legit. We can do the calculation if need be. Just going to unsolder this. And then the top pins here. Okay. I'm going to reach in from the other side. Trying to get around some wire looms and things that are kind of in my way, so bear with me a second. Unplug that. And let's wiggle this out. All right. You're out. See, this little thing here. 2 amp relay. Ugh. And let's see if I can make a little more room for what I need here. And then we'll get our big beefy 8 amp relay. And it's going to be a little bit tricky trying to see where this needs to be inserted. So bear with me a moment here. I have to work in this tight spot because all the wiring's shoved up in where the relay is. Almost got it. There we go. All right, that's in there. Now we'll go ahead and solder it up. And then we'll retest it again. You always got to check these protection relays because they're probably the leading cause of amplifier channels dropping out at lower volumes. At higher volumes, you don't really notice it because the more current is flowing, the more likelihood it's going to arc across whatever crummy contacts there are, so you don't notice it as much. But at lower volumes, when there isn't a lot of current flowing, the crummy contacts usually reveal their ugliness and cause channels to drop out and such. All right, so that guy's soldered in there. Let's go ahead and see what it does now. All right, so let's turn this on. Click. All right. And we got our nice channels here. And if I tap onto relay now, yep, doesn't affect it. So we're good. This thing's happy. So defective amplifier IC and definitely a bad protection relay. But those have been cured, and it doesn't look like I need to clean any pots or switches. They're pretty happy. So this goes back together. Anyways, hope you guys enjoyed the video, and more stuff to come.